solution to TK06 that's tested and everything. And ultimately what you're going to be doing is substituting out that storage layer, which is currently a flat file system like you all had implemented, with a SQL Alchemy and SQL table, SQL model persistence layer. I'm going to mention that I think it's worth everyone cloning this and getting started with it, but there is going to be an opportunity for those of you who feel very good about your implementations of TK06 and stand by it and want to modify it directly. There is a path, and it'll come with a little bit of extra credit, like 5% extra credit, for you to take your TK06 and use that as the basis rather than our starting point. But I think it's worth seeing the starting point, and if the extra credit path is what you wind up choosing to do, you'll gain from taking a look at this and seeing some of it set up first. But you will have a little bit more work to do in setting up your dev container and setting up Docker Compose and getting the database set up and all of that if you go your own route. What this basis will set you up with is a working Docker Compose dev container that has the DB like we saw on Wednesday running in a separate process. And what I want to show you today, once we've had a chance to briefly take a look at this, is a tool for taking a look at the data that's in your Postgres database, because you can access that directly from your VS Code. There's a plugin for that we have set up in this. So let's spend 3 minutes or 4 minutes trying to clone this, get this going. We'll be walking around. Hopefully we don't run into as many dev or Docker container issues as last time. And then I'll come back. Oh, maybe we will immediately. Is it private? Oh, it doesn't exist. So I think I made it private. Hold on. Sorry about that.
TK07-starter. Someone mentioned that. I'm not sure if that.
Yeah, sorry, it's -starter. My bad. Sorry about that. Once you have it up, poke around, see what you can find, run the tests, and see what the starting point is. 2 more minutes, and then we'll talk through a few things together. 2 more minutes. One more minute. All right, I want to talk through a few things, and then after I talk through a few things, I'm going to give you all some time to start thinking about and maybe talking at your table about what you would try and take on first as the TK07 starting point. While I finish up, I need to get the submission for today going, and I'll do that as soon as we get through this, and then you'll be able to submit attendance for today. So I'm going to jump into TK07. That is this one. Great. Again, this is, so if I were to run the dev server and try out one of our stories, so /scripts run dev server. I'm going to open the API on my local host. And we've got, again, sort of the minimum viable little link sharing API that you all have been building up. And so if I were to look at, let's make a link, I'm going to try it out real quick. We'll just give this a go. And it looks like we were able to successfully create that link using one of the examples we set up in the system. And now, if I were to actually go and test this out, one way is to use the API, but something that you all noticed is that when you use this API Explorer to go to one of the redirected URLs, you get something that looks a little funny. You get this, well, here we get back the HTML and the response body. We didn't actually see the 307 temporary redirect response code because our browser actually follows that before we can catch it in this API Explorer. But we could also test that from just navigating to that URL directly. So localhost 8000 /COMP423, because I'd made that short link, and boom, that redirected me. And if I had pulled up my inspector and gone back to this, gone to networking, and I am recording, so if I were to try going to that again, what we would see at the very first request response is we gave the get method to that URL, and then we had the 307 temporary redirect response, and then our browser loaded the new web page, right? So we could test that, and then I can test the final endpoint of Amy listing all of the links. I can try that out and see, okay, there's this response, and you'll notice that I do have the hit tracking counting here where we've hit this link 3 times. And if I were to go back to it one more time, we could convince ourselves, I make this request one more time, and now we have that hit counter was updated by 1. All right, so the starting point for the routes and the layers of this system it's going down and using the same storage that we've been working with so far at the flat file level. But you'll notice that in this starting point, you do have a db.py file set up that has some of the helper functions for creating the database and tables, dropping the database and tables, and so on. We also have a very basic entity. So the link entity is differentiated now from a link model. So the link model is Pydantic. The link entity is the SQL model table, where we're specifying we're going to use slug as the primary key in this simple little example. If you all wind up going the extra credit route and modifying your existing TK06, you're free to choose a different database implementation than this. I just wanted to keep this as minimal as possible for you all. We have 100%, so if we run, one other thing that I noticed in some of the submissions for TK06 was folks didn't necessarily run through the Q&A. So one thing that's like free feedback is the QA script, right, which goes through rough for formatting, it goes through rough for linting, Pyrite for type checking, and then our unit tests, and then finally our full integration test suite and coverage, and we've got 100% coverage as your starting point. But because you all are, like, part of this exercise is the engineering effort of substituting a layer that's actually the bottom layer of our system, the storage layer, with a new implementation, you're going to have some challenges in deciding, which tests do I keep, which do I get rid of. You're no longer going to need some of the storage links once you actually get all the way to having replaced that layer with the database layer. And the process for working your way there and testing your way there is an incremental one. And we encourage breaking it down into small steps. Right? What else did I want to say about this? Right. So after you've done if you do wind up doing anything specific to your schema, or especially if you're taking on the extra credit, do remember that you need to reset the database in some way in order for those models, those tables to exist in the database, in the Postgres database. Now this container should have, and maybe someone sanity check this for me, a Postgres plugin set up. And I wanted to show you all this really quickly. So you'll notice an elephant icon that's the Postgres icon in the sidebar. Are you all seeing that? Yep, cool. So when you see that, I believe your view, let me just see if I can delete this. Cool. So you have to set up a connection to your server to be able to see it. And we've actually talked about this in the past. Where would this information come from? And I want to actually remind you that your Python has to configure itself to be able to specify the server name, the username, and the password as part of the connection string. So we could go look at that really quickly just to remind you where this is in your source code. So in source, if we go to the database, let me see if I can get these side by side. This connection URL that you're seeing is where in one string we're actually codifying all the information we need to connect with one little caveat for how we're running the Postgres server. But the server name is this @db. db is our server name, and remember that was set up in our Docker Compose configuration. We have the Docker Compose DB service set up. It's named DB. That's its host name. That's where that comes from. The username is what comes right after this, the // of our protocol prefix. So Postgres is our username here. And then we have a very secure password. The password is password. So Postgres is the username. Password is the password. And we're using the standard port. The next question is, what is our database name? So I had specified this in another file we could go look at real quickly. It's links_db. But let me just show you where that came from, or where we actually set that up. So that's in the util resetDB file. And as part of this script, we have this globals tuple that has linksDB, and then we also go ahead and set up a test database so that your tests can test against that rather than your development database. So there's one other little caveat to this connection. So if I were to try this connection right now, I would see that it fails. I can try it. And the failure message is going to be this. We're trying to establish a secure connection to your database, but the database isn't actually accepting secure connections. And that's because in development, we don't really care about the fancier SSL-based connection to our server. And by default, when we use this Postgres image, it's not using the secure setting. So the way around that is you go to advanced, and as the SSL setting, under mode, we would just either allow it or disable it. So right now, like the default of this plugin is a sensible secure default, which says don't connect to anything that's not secure. But this is all running on your machine, right? We don't care about anything we send within the context of your own development environment. If we were connecting out to a Postgres server that was running in the cloud or something like that, we probably would care because we wouldn't want people to see the commands we were sending over the line. But for our development setup, we don't care about that. So I'm going to set that to disable or allow. And now we've got a connection. And if you pop that open, it's nested a little bit deep in here. But if we get down into linksDB, schemas, public, tables, and finally the link table is the table within this Postgres system that we are using, that our SQL model is connected to. And one of the cool things is we can run a select command. So I right-click on that table, and we can select the first 1,000 rows of that table. Well, we've only set up 2 rows to that table, which you can see here, and that's coming from the resetDB script where we seeded our development server or development database with these 2 rows. But you can also, if you wanted to play around with running SQL against your database, you can do that here. It's really handy when you're working with a database system to have some kind of a GUI into it to be able to run queries outside of just the command line. It's really helpful for debugging. This particular plugin is made by Microsoft, and it's primarily for viewing data. I don't believe you're able to edit data in tables directly through this unless you wrote the SQL by hand. If you spent a lot of time on databases and systems that integrated with them, I'll mention that there are tools that are full-on like Windows and Mac applications. The most popular one for Postgres is called pgadmin. It's an open source tool. You don't need to download this or worry about it. I just want to mention it briefly to you that I'm not even going to try and connect or fix this issue. This is a tool where I could, if I wanted to go through the trouble, I could connect up to the CSXL's Postgres database, which is running on Carolina Cloud Apps. And that's a tool where you can edit rows directly and edit schema directly through a GUI process. And it's really nice for heavier weight database work. But for now, just to convince yourselves that some change that I made a new link, I want to see does that actually persist to my database. This plugin is a really handy tool for doing that. So as I mentioned, your first task is, or the whole point of this task is replace the store layer, right? So everything that's in store, we're going to effectively get rid of. We're not going to use JSON file IO, link store factory anymore. What we're going to wind up using is services, and we'll only have one. Link service is going to wind up injecting a session, right? But I don't have that dependency injection, like that link hasn't been made for you. It's going to be on you all to inject the correct thing and start working with sessions in the correct way within this service, and think about taking on the problems of how do we set up that service in as an injection, and then how do we persist the data. For the create method of this particular service, you'll notice we get a link model. Ultimately, you're going to need to persist a link entity, which that class name is just link, within the context of a session. And so you've got some interesting challenges in going back and forth between the link model representation that you get from the fast API layer to the link entity. And these are the types of questions and problems that you'll be addressing as part of this next task. You'll also need to test the services, and the current reading that's out, and it's due tonight, that many of you have already completed, is on how to set up a project with tests, how to be sure that you set up fixtures in a way that your tests are isolated from one another. We're not providing that here so that you have the experience of setting up that little bit of infrastructure. You can look at what we did in class on Wednesday and get a working example that you can translate over. And that process of translating the fundamentals is really important for if you wanted to go out and set up a database in your own project. These are some of the steps you would need to take to do it in a realistic way. If you do take the extra credit option and start from your own TK06, you and your partner will be working independently on that, because these steps we want everyone to have a strong handle on individually. But you're going to have to set up the dev container to work with Postgres and take a few other preliminary steps to get yourself closer to the position that this repository is in. But you can look to this repository as some hints or guidance on what would be required to get you here and have a running Postgres database. Previously, we did not have more than just the singular container. All right? So I'm going to give you all the next 10 minutes to talk amongst your table on where would you even start with this? How would you get started? What would be the first thing you would want to try? And in the meantime, I need to set up the submission form for attendance, and I'll do that right now. All right. I have one more quick announcement to make. Quick announcement. So in just a second, I'll give you the instructions for submitting for attendance. There's going to be an announcement that goes out from me on Canvas that is a second submission on TK06. And the primary reason for this is we're going to keep the first submission. Many of you submitted as a team. That was great. Some of you submitted individually. That was fine. There's ambiguity on that. That's my fault. Sorry about that. But we're going to have another submission that allows us to specifically ask you for your GitHub username, and then a joint, and this is going to be a joint submission, so that when we apply grades for actually reviewing the code, we can do it the same to each of you and not individually in GradeScope. So there's nothing that you need to do more on the TK06 side. Although I will say, if you do open up TK06 and run the QA script and you still have formatting issues or type issues or you're not passing tests, please be sure QA is actually passing. We are going to run that QA script, and there's still time for you to fix that right now as just a baseline. I wouldn't spend too much time on it, but you don't want to lose points for not having run rough format on your code. For attendance, just take a selfie of your table and upload that. You don't need anything on a whiteboard or anything like that. And that's all we have for you today. So if you want to keep working, great. We have about 7 more minutes in class. Otherwise, go enjoy the weather.